Hello and welcome back to another lecture from organic chemistry. In the last couple of lectures, I was talking about mass spectrometry, and we practiced some example about how to use the different fragments in order to find the unknown samples. And then this lecture and next one, I will try to practice the fragmentation of a bunch of organic molecules that they have functional groups. And I'm going to start with alcohol. And alcohols can go through two ways of the fragmentation. The first one, it will be alpha cleavage, and the second one, it will be dehydration. The alpha cleavage, and if you look at OH group, wherever OH is attached to, the backbone or the carbon, that carbon, we're going to call it alpha, and the neighbor, it will be beta. So we're going to find the alpha and beta, and we cut the molecule from that, through that bond, technically, or we cut that bond. And why do we do it? And maybe you should write this one as a note. If you have a heteroatom like oxygen, nitrogen, or any atom that it has a lone pair, those atoms, the heteroatoms, they can use one of the lone pair and share it with carbon in order to stabilize carbon. Remember, carbon is not going to be octet. In order to make it octet and stable, we need to, borrow an electron or lone pairs from somewhere, and oxygen or nitrogen are capable of doing it. And so we will get the cation that it can be stabilized by resonance, and the resonance, it will happen through a lone pair of oxygen. Another way is dehydration. Dehydration, we will lose a water molecule, and remember, water molecule is neutral, and because it doesn't have a charge, we're not going to detect it. But the overall thing that is happening, whatever was the molar mass, it will go down by 18, because molar mass of water is 18 gram per mole. So that's the reason we say minus 18. Now, how can we get this one? Again, we will find the alpha carbon. If the beta carbon happen that has a like a hydrogen, in that case, you can take hydrogen and OH from alpha and beta, and that's going to generate water plus alkene molecule. Let's practice some example. And here is the example that we have one molecule, and then like it's an alcohol, and as you see, we have two betas, and the betas are identical, and also we have gammas, and the gammas are again identical. Whenever you inject this molecule to a mass machine, the first thing that's going to happen, it will be bombarded by a bunch of electrons, and we will get radical cation. Again, I say radical cation, and I want you to look to the area that I'm going to highlight. So we have an oxygen that has two lone pairs, but whenever we take an electron from the system, that one electron will be taken from oxygen, and it's going to leave us only with one electron. Okay, so one of the lone pair turned to radical. Now we have a radical, and because we took electron from the system, the charge, it will be positive, and so that's the reason I call it M plus. M plus means we are dealing with a cation, and I put also one single electron there to show that I have a radical. Now that radical, it can go through two different mechanisms of fragmentation: alpha cleavage or dehydration, and I'm going to practice both of them. But for now, the mass over M over Z for the radical cation and is 172. Okay, so the alpha cleavage, I'm going to find the alpha, and between alpha and beta, I can cut the molecule, and so I'm going to cut the molecule from this region, or I can actually do it from here, and either one, and it will give me the same product. So both of them are identical. Okay, and so let's say we decided to cut the molecule from there and see what will happen. And in that case, this bond, it will be gone. So I'm not going to have that bond anymore. And the thing that is going to happen, one of the electron, it goes to this carbon, and the second one, it will go to that one. Okay, remember, each bond is made of two electrons. So now I will have a carbon here that's, yes, it does have hydrogen. Okay, and there is hydrogen there, and also now it has one electron. Okay, and what else? And next thing is, I'm going to get a carbon here, that carbon, it will be radical. Okay, so now let's rewrite them. Okay, this one, it will be okay, tertiary butyl group, and then we will have C, H, H, and one electron, so that's radical. We're not going to see this radical. But now what will happen to this species? This species, okay, I'm going to also write this one. Until now, the charge is okay, plus dots. I want to say that I'm dealing with radical cation. Okay. And now what will happen with that second species? So this one, I'm going to have a tertiary butyl group. Okay. Next, I will have CH2. And then I have a carbon. That carbon, it has one hydrogen and is attached to oxygen, OH. Oxygen, it has one lone pair and one electron. And carbon also has one electron. Now, what is going to happen? We're going to share. Maybe I should rearrange the electrons. I'm going to put one lone pair here and that electron there. Okay, I'm going to share those two radicals in order to form a double bond, and that's going to give me this structure. The charge on oxygen, it will be positive. Okay, why is positive? You can easily draw a circle around around the oxygen in order to calculate the calculate charge. Oxygen is a group 6. I see only 5 electrons around it, so it will be +1. Okay, and this one, it will be a cation, so we're going to be able to detect it inside the mass, and the m/z for it is going to be 101. Okay, and how about the radical? The mass for radical, I'm saying mass, or I can say the molar mass. Molar mass is 71. Okay, remember we started 172. We lost a radical is 71, and we got one species that is a cation and is 101. And we will see this inside the spectrum, but the radical is not going to show up. So if I want to, like summarize my product, I'm going to say the product will be this tube. I will get a radical plus a cation. Radical will not be seen, but the cation we will detect it. And this species, we got it through alpha cleavage. Now, what will happen if we go through dehydration? The dehydration, we need to look to the beta carbon and see whether there is a hydrogen there or not. Clearly, we do have hydrogen there. Now, this hydrogen, it has a sigma bond with carbon, so 2 electrons are there. And I'm going to take here one, like, we're going to take one of the electron, either from oxygen or from the hydrogen. We're going to pair them in order to form one molecule. So how about this? Let's go after hydrogen. We're going to take hydrogen, and that's going to give us, like a water molecule. And what will happen with the second electron? The second electron, it will come back to the carbon. Okay, we're going to share it here. And remember, the OH is using 2 electrons to technically get attached to carbon. So one of these electrons, it will get back, and it will be shared with neighbor carbon. And so the output will be something like this. We get water molecule, so I get water molecule. It will have 2 lone pair, and that's neutral. The mass or molar mass for it is 18. And the second species that we will get, it will be this. Remember, we do have one hydrogen here. Also, there is one hydrogen there. I did not show it from the beginning. Okay, so there is another hydrogen there. And now if I take those 2 electrons, that's going to give me a double bond. So I get an alkene plus water molecule. And remember, the total charge, we wrote it as a plus dot. We removed a neutral molecule, and that's water. And so that's not going to change the charge because it's just neutral. And so whatever left still is going to have a charge. And also we call it radical. Again, why do I call this one plus dot? Because I'm dealing with the species that it is a radical, and it's a radical cation. I removed neutral water from it. That's not going to change the charge. So still I will have a radical cation, and the mass m/z for this species is 154. Well, water is 18. Okay, so if I say here 172 minus 18, that's going to give me 154. So that's the reason we say this, this mechanism, or the dehydration is, it can be written as m-18 because we are losing one molecule. Okay, I'm gonna stop the lecture here, and next lecture I will try to practice some example about fragmentation of amine and carbonyl functional groups. Thank you very much.